Hey everyone! I think day by day, a lot of new open-weight generation models are getting bigger and bigger. I wonder if in the near future we may need a supercomputer to run an open-weight model. Meanwhile, Alibaba just amazed everyone with their small open-weight 6B parameter model called Image Turbo, which is a distilled model. It only needs 8 to 9 steps to generate an image, and it is amazingly fast on my GPU. So, the model was released under the Apache 2 license, and that is a really good thing. In this video, let's see where we can download the model and how to run it in ComfyUI. So, let's get started. The download link for Image Turbo is available in the description. Once you open the link, you will see a page like this. It is the official repo of ComfyUI. To download the model, click on Files and Versions. Then click and open the Split Files folder. Here we have 3 folders. One is Diffusion Models, which contains the Image Turbo model. The second one is the Text Encoders folder, which contains the text encoder we need for the Image Turbo model. Then there is the VAE folder, which contains the VAE file. First, let's open the Diffusion Models folder. So, in here we can find the diffusion model called Image Turbo BF16.SAFA which is in BF16 format. Use the download button to download the model. If you want an FP8 version of this model, which is also available in another repo, let's open that page. Here we can find the FP8 models. You can try both FP8 models to check which works best for you. The download link for these models is also available in the description. Now let's move on to the text encoder, which is available in the ComfyUI official repo of Image Turbo. So, in here, let's go back to the parent folder called Split Files. Then let's open the Text Encoders folder. And here we can find the QN34B model. Use the download button to get this model. Now let's go back to the parent folder. Then click and open the VAE folder. Here we can find a VAE called ae.safatensors. This is the same VAE file used for Flux1 models. If you are already using Flux1 models, then you may already have this VAE file. If you don't, use the download button to get it. Now, after downloading, let's see where we need to put the downloaded files. Open the Downloads folder. First, let's select the diffusion model, which is Image Turbo, and cut the file. Then, open the ComfyUI Models folder. Next, find and open the folder called Diffusion Models, and then paste the file. Then, let's go back to the Downloads folder. Next, let's select and cut the text encoder, which is QN34B. Again, open the ComfyUI Models folder. Then, open the folder called Text Encoders. Paste the file. Again, go back to the Downloads folder. Select and cut the VAE file, which is ae.safatensors. Then, open the ComfyUI Models folder. Find and open the VAE folder, and then paste the file. Now, let's switch to ComfyUI. Then, refresh it using the R key on the keyboard. So, let's start using the Image Turbo. The workflow I am using here is available for download, so check the description. Let me give an overview of this workflow. In the Load Diffusion Model node, we selected the BF16 version of the Image Turbo model. If you are using the FP8 model, then select that instead. Next, there is the Model Sampling Aura Flow node, which is currently in bypass mode. We'll keep it that way. Then we have the Load Clip node, which loads the text encoder, the QN34B model, and the type is set to Lumina 2. Next, there is the Load VAE node, which loads the VAE model. Then we have this Positive Prompt node for writing our prompt. As usual, the positive prompt is where we type what kind of image we want. Another thing you should know is that this model does not have any negative prompt. So, typing anything in a negative prompt for this model has no use. Then we have the K sampler. I am using 9 steps, a CFG value of 1, and the sampler I am using is Euler. The scheduler is simple, and the denoise value is 1. Then we have this empty SD3 latent image node, where we can set the output resolution. I am using a width of 1920 and a height of 1088. You can also try using 1024 for both width and height, which will make the generation even faster. If you want a portrait resolution, just interchange the values. Then we have this VAE decode node to transform the latent image into a pixel image. Next, we have the Save Image node for saving the image. So overall, this workflow is so simple to use. Now, let's generate an image. I have already written some text inside the positive prompt, so let's run the workflow and see the result. So the generation is completed. Now let's take a look at the image. As you can see here, the result is pretty good. Now let's check the generation time. On the terminal, you can see here the generation took around 90 seconds, which is pretty impressive. And in upcoming generations, the generation time will be even faster than this. So let's try another prompt. I have written some prompts in my notepad, so let's copy one of them and paste the prompt in the positive prompt node. Then, let's run the workflow and wait for the result. The generation is finished. Now let's take a look at the image. As you can see here, the result is really amazing. Remember, it is just a 6B model, and let's check the generation time. So this time, the generation took around 52 seconds. That is pretty fast. Now let's try another prompt, which is about Elon Musk eating something. Let's copy the prompt and paste it inside the positive prompt node. Then, let's run the workflow and see the result. The generation is finished. Let's take a look at it. As you can see here, the result is pretty amazing, and he really does look like Elon Musk. And let's check the generation time, which is around 50 seconds. Well, that generation is faster than before. Now, let's try another prompt. This time, we are going to use a prompt that includes text rendering. So, let's copy this, and let's check the model's text rendering capabilities. Paste the text prompt in the positive prompt node. So, when you want to render text, always make sure the text is inside double quotes. Now, let's run the workflow and check the result. The generation is completed. Now, let's take a look at the image. Well, the image looks really good, but the text is having some issues. The text got duplicated. The prompt I used didn't say to put two power texts into the image. So, there the model had a failure to render text. Now, let's try another prompt which includes text rendering. Let's copy this to the positive prompt node. And now let's run the workflow and see the result. The generation is finished. This time, text rendering is correct, no duplication, and the image looks really good. And now, let's try doing simple image-to-image generation with this model. The download link for the image-to-image workflow is also available in the description. Now, let's switch to the image-to-image task. The main difference between the image-to-image workflow and the text-to-image workflow is that in the image-to-image workflow, we have this image loader node for loading images. Then, we have this image scale to total pixels node for upscaling images to 1 megapixel. Then there is the VAE encode node for encoding the image into latent, and it is connected to the K sampler. In the K sampler, we are using a denoise value of 0.6. Depending on your image and prompts, you may need to adjust the denoise value. So here, I have loaded an image of a house. I also wrote a prompt about an abandoned house. Let's run the workflow and see the result. The generation is completed. Now, let's take a look at the image. As you can see here, the generated image composition looks similar to the image we imported, but there are a lot of things that have changed. So, like this, you can do simple image-to-image tasks with this model. Also, you should know that Alibaba is already working on an image editing variant of this model that is soon to be released, which is amazing. And also, this model comes with fewer restrictions. It can do a lot of NSFW images. Well, because I have to follow YouTube guidelines, I cannot show those images. So try the model for yourself and let me know what you think about this model. See you soon with another video. Thanks for watching. Don't forget to like, share, and subscribe to this channel.